Photogrammetry is a favorite exam subject for the special California Civil Engineering Surveying exam. So let's go work through one of these. As I told the folks in the review course for the surveying exam, there's basically two kinds of questions on the exam. One kind is quantitative. They want you to compute everything. The other kind is qualitative. They want to talk to you about terminology, usage, processes, meaning, that kind of thing. When we get to photogrammetry, it's all computational. It's all quantitative. So they would like us to come up with the elevation of the plane. That's another way of saying flight height is the typical terminology that's used. Flight height is always taken from the ground up. A lot of people think it's going to come from something like mean sea level. It's not. It's always from mean terrain, it's called. So that's one major bugaboo people have. So when we talk about the flight height, we're talking about h. Now, they're asking about elevation of the plane. Evidently, elevations are going to be off of mean sea level. So we have to add in whatever this value is here to the flight height that we can actually compute in order to get the elevation of the plane. So it's a distinction, I understand. It's kind of strange, but all of our computations in photogrammetry have to do with h. If you want an elevation, you have to figure this out, which typically is going to be given to you, and then you can figure out the elevation of the plane. Okay? They tell us the elevation of the ground right here, so they tell us what that value is. All we got to do then is figure out h. So you can see it's kind of contrived. We're simply going to compute h like we do, but we're going to report it as an elevation, having to add on this 1280. So not a big deal. Scale. I mentioned to you that when you see 1 to 12,000, that's the same as saying 1 inch on the film is equal to 1,000 feet on the ground. How come? Because this is unitless. One dimension, or one unit, I should say, on the film that's in the belly of the plane represents 12,000 units on the ground. That's what scale means. So 1 inch on the film up here, which typically is a 9-inch by 9-inch square, 1 inch on that film represents 12,000 inches on the ground. 12,000 inches is 1,000 feet. So whenever you see this, you're going to be using 1 inch on the film equals 1,000 feet on the ground. You're going to be using it. So warned you about that in class. So we need to figure out h. So he tells you what I've been telling you, right? And he comes up with his old drawing that explains what h is over here. Now, there's two different ways to compute the scale. Once you have the scale, you can back that into h, flight height above mean terrain. Okay? So one way to do this, excuse me, phones are ringing in the office. Yep, teaches me to stay late. Okay, so there are two ways to compute scale. The first one is the ratio of the focal length to the flight height above mean terrain. That ratio can be your 1 to 12,000. The other way to compute it, well, let's grab another color, is to take the ratio of this blue line up here, which is what you have exposed the negative to what it is covering on the ground down here in blue. So the ratio of the blue to the blue, or the ratio of the red to the red, are numerically going to be the same in any given problem. Now, because you want h, you're looking to see, can I grab that quickly by knowing the ratio of the focal length to this is 1 to 12,000 given. Okay? And so that's the one he's going to use. So some books you're going to see that the scale is the red ratio, and other books you're going to see it's the blue ratio. You need to understand both are true. Both are numerically the same, and you're going to use them interchangeably. Okay, so he isolates his flight height. He says if I only knew the scale, which is 1 to 12,000, and if I knew the focal length, which was given as 6 inches, which is a standard value anyways, he plugs those in. Now, the deal with this ratio here is its units consistent. So if you've got inches up here, understand that's what you need to have down here. So that's why you put a unit conversion in. Okay. And he comes up with a flight height of a very reasonable 6,000, but he has to add that on to the difference between mean sea level, or his horizontal datum, and his mean terrain, which was given as 1280. So he adds that on, and there he is with his elevation, 7280.